In 1917, Henry Ford looked at his famous Model T assembly lines at Highland Park and realized he had a problem. He had mastered the speed of assembly, but he was still a slave to the supply chain. He was tired of waiting for rubber from overseas, steel from Pittsburgh, and glass from independent glaziers. He didn't just want to build cars. He wanted to control the very elements of the earth they were made from. His vision was a concept called vertical integration, a factory so massive and so self-sufficient that it would function as a closed-loop industrial organism. To build it, he chose 2,000 acres of swampy marshland along the Rouge River in Dearborn, Michigan. This was the birth of the River Rouge Complex, the most ambitious construction project in the history of the industrial world. The scale of the Rouge was terrifying. Ford didn't just build a factory. He built a city that required its own weather system. He dredged the river for miles, carving out deep water channels so that massive Great Lakes freighters could sail directly into the heart of the plant. He laid 100 miles of private railroad tracks within the gates and built a powerhouse with 8 towering smokestacks that became the Eiffel Tower of the American working class. This powerhouse produced enough electricity to light up the city of Detroit, but every single kilowatt was consumed by the machines inside the Rouge. It was a fortress of brick, glass, and steel, designed with one single, obsessive purpose: to take raw materials in at one end and drive a finished automobile out of the other. Inside the gates, the complexity of the engineering was staggering. Ford abandoned the traditional multi-story factory design, opting instead for massive, single-story structures with soaring ceilings and glass walls designed by the legendary industrial architect Albert Kahn. This allowed for a linear flow, a river of production that never stopped. In most factories, parts were moved by hand or horse-drawn carts. At the Rouge, everything moved on a 27-mile network of overhead conveyors. Gravity and electricity did the heavy lifting. Ford was the master of matter, transforming a desolate marsh into an industrial cathedral where 100,000 men worked in a choreographed dance of fire and metal. This was the beginning of the Age of the Rouge. It was a place where the air was thick with the smell of coal and molten iron, and where the sound of 4,000-ton stamping presses echoed like thunder. Henry Ford had created the ultimate machine, a factory that didn't just manufacture cars, but manufactured the very materials the cars were made of. But as the first fires were lit in the blast furnaces, the world began to realize that the Rouge wasn't just a factory, it was a social experiment. It was a place where the limits of human endurance would be tested against the relentless pace of the machine, setting the stage for a conflict that would define the American worker for a century to come. The Rouge was alive, and it was hungry for more than just iron ore. To truly understand why the River Rouge was the most powerful factory ever built, you have to ignore the cars and look at the clock. In the early 20th century, the standard way to build an engine involved sourcing parts from dozens of independent foundries and machine shops across the country, a process that took weeks of shipping and logistics. At the Rouge, Henry Ford achieved a feat of physics that still boggles the mind of modern engineers. He turned raw, red iron ore into a finished, running V8 engine in exactly 48 hours. This was the 48-hour miracle, a relentless, high-speed conversion of matter that proved that time was the most expensive material in the factory. The process began at the Rouge's massive deepwater dock. Every morning, Ford's own fleet of Great Lakes freighters, leviathans like the Henry Ford II, would arrive from the mines of northern Michigan. Using gargantuan Hewlett unloaders, thousands of tons of raw iron ore, limestone, and coal were scooped from the ships and dumped onto a primary conveyor belt. Most factories would store this ore in piles for weeks. At the Rouge, it never stopped moving. The ore traveled directly into the High Line, a massive concrete structure that fed the blast furnaces. Inside the blast furnaces, the chemistry of the earth was violently rewritten. The furnaces were kept at a constant, terrifying 2,800 degrees Fahrenheit. As the iron melted, it became a glowing, white-hot liquid. In a traditional setup, this pig iron would be cooled into bricks and shipped elsewhere to be remelted. But Ford hated wasting heat. At the Rouge, the liquid iron was poured into specialized ladle cars, giant insulated thermoses on wheels, and rushed while still molten to the foundry. This meant the metal never lost its liquid state from the moment it left the furnace to the moment it was poured into an engine mold. This direct pour method saved millions of dollars in fuel and hours of time. The foundry at the Rouge was a 30-acre cathedral of fire and sand. Here, thousands of workers used high-speed molding machines to create sandcasts for the engine block. The molten iron was poured into these molds, and as it solidified, it was moved onto a 2-mile-long cooling conveyor. By the 24-hour mark, what was once red dirt in the belly of a ship was now a solid, heavy V8 engine block. But it was far from finished. It moved immediately into the machining plant, a forest of 10,000 specialized machines. Here, the block was clamped into place and subjected to a mechanical assault. Massive drills bored out the cylinders, diamond-tipped grinders polished the surfaces to a mirror finish, and synchronized taps cut the threads for every bolt with sub-millimeter precision. While the engine was being machined, parallel rivers of production were feeding into the main line. Ford's on-site glass plant was using a revolutionary continuous ribbon process to roll out windshields, and his tire plant was cooking raw rubber from his own plantations in Brazil. By the 36-hour mark, the engine met its internal components, pistons, crankshafts, and valves, all manufactured in adjacent buildings. At the 48-hour mark, the engine was lowered into a waiting chassis. A worker filled the radiator with water, splashed a few gallons of gasoline into the tank, and turned the key. The car roared to life and was driven off the line under its own power. At its peak, the Rouge was breathing out a finished car every 49 seconds. It was a 2,000-acre heartbeat that proved that if you owned the fire and the ore, you could conquer time itself. If the assembly line was the heart of the River Rouge, its infrastructure was the nervous system. To keep the 48-hour miracle from grinding to a halt, Henry Ford had to build a facility that was entirely self-sustaining. The Rouge wasn't just a factory, it was a private industrial city, spanning 2,000 acres and operating with a level of complexity that surpassed many small nations. At its center stood the powerhouse, a massive, Art Deco masterpiece of engineering with 8 iconic smokestacks that became the symbol of Ford's dominance. This wasn't just a boiler room. It was the largest private power plant in the world, producing enough electricity to light up a city of 1 million people. Every single watt was used to drive the massive stamping presses, the glowing blast furnaces, and the 27 miles of overhead conveyors that never stopped moving. To fuel this city of fire, the logistics were staggering. The Rouge consumed over 500 tons of coal every single hour. To manage this, Ford built a private railroad system within the plant gates that consisted of over 100 miles of track and 16 specialized locomotives. These weren't just for moving parts. They were the arteries that carried the lifeblood of the plant. At any given moment, hundreds of rail cars were moving through the complex, carrying everything from molten iron in specialized bottle cars to finished engines and scrap metal. Ford's obsession with efficiency meant that nothing, not even a handful of sawdust, was wasted. He built a wood distillation plant on-site to turn scrap wood into charcoal briquettes, creating a side business that would eventually become the Kingsford Charcoal Company. The sheer scale of the water and waste systems rivaled that of a major metropolis. The Rouge required over 700 million gallons of water every day, more than the city of Detroit at the time, primarily used for cooling the massive blast furnaces and the glass rolling lines. Ford built a massive intake system from the Detroit River, filtering the water to industrial standards before pumping it through a network of pipes that spanned the entire 2,000 acres. Even the waste from the iron-making process was monetized. The slag, the stony waste matter separated from metals during smelting, was processed on-site and turned into high-quality cement for the very roads the Ford cars would eventually drive on. This was the ultimate expression of industrial cannibalism. Every byproduct of the factory was consumed by another part of the factory. Working inside this city of fire was a sensory experience that few could forget. The air was a thick cocktail of coal smoke, ozone from the welding lines, and the metallic tang of the foundry. To keep the 100,000 workers from being overwhelmed by the heat and fumes, Ford and his architect, Albert Kahn, designed the buildings with monitor roofs, giant, sawtooth-shaped glass ceilings that allowed hot air to escape and natural light to flood the floor. Yet, despite the smoke and the chaos, Ford enforced a laboratory-like discipline. He employed a cleaning army of 5,000 men whose only job was to scrub the floors and paint the walls white. He believed that a clean factory was a productive one. It was a place of extreme order and extreme violence to the senses, a 2,000-acre machine that demanded absolute obedience from the men who tended its fires. The Rouge didn't just manufacture vehicles. It manufactured a new way of life, where the rhythm of the clock and the heat of the furnace dictated the existence of a generation. If the foundry was the soul of the River Rouge, the stamping plant was its brute muscle. While the engine was being cast from molten iron, the body of the car was being born in a building that housed the most powerful mechanical presses ever designed. In a typical modern factory, parts are often made of plastic or composite materials. At the Rouge in its prime, everything was heavy-gauge steel. To turn a flat, cold sheet of metal into the complex, aerodynamic curve of a fender or a hood required a force that felt like an act of God. This was the domain of the monster presses, machines 5 stories tall that exerted upwards of 4,000 tons of pressure in a single, earth-shaking stroke. The process began with coils of steel, rolled out in Ford's own steel mill just a few hundred yards away. These massive rolls were fed into blanking machines that sheared the metal into precise rectangular sheet. From there, the sheets were grabbed by mechanical fingers and fed into the jaws of the presses. The sound inside the stamping plant was not a noise. It was a physical vibration that could be felt in the chest of anyone within a mile. When the upper die of the press came down, it didn't just bend the metal. It forced the steel to flow like a liquid into the intricate shapes of the lower die. This required a deep understanding of metallurgy. If the steel was too hard, it would crack. If it was too soft, it would tear. Ford's chemists worked around the clock in the on-site labs to ensure the recipe of the steel was perfect for every specific part of the car. The scale of these machines was almost incomprehensible. Many of the presses were so heavy they had to be built on their own independent concrete foundations, reaching 50 feet into the Michigan clay to prevent them from shaking the rest of the factory to pieces. A single die set, the heavy steel molds that gave the part its shape, could weigh over 40 tons and take a team of master tool and die makers months to carve by hand. Yet, at the Rouge, these dies were changed with the speed of a pit crew. Ford's engineers developed a quick-change system that allowed the factory to switch from stamping doors to stamping roofs in a matter of hours, a level of flexibility that would later be studied and copied by Japanese automakers decades later. But the stamping plant was more than just a collection of big machines. It was a masterpiece of material efficiency. When a fender is stamped out of a square sheet of steel, there is always scrap, the triangular corners and edges that aren't used. In a normal factory, this scrap would be sold to a recycler for pennies. At the Rouge, the scrap was a resource. Small parts, like brackets, washers, and hinges, were designed to be stamped out of the holes left behind by the larger parts. Whatever was left after that was dropped through chutes in the floor, where a subterranean conveyor system carried it directly back to the steel mill to be melted down and turned into a fresh coil of steel. It was a perfect, cannibalistic cycle where nothing was wasted. The City of Fire was a closed loop, and the stamping plant was the place where that loop was forged with a weight of 4,000 tons of pressure. Here, the raw power of the industrial age was refined into the elegant lines of the American automobile, one thunderous strike at a time. In the early 1940s, the world's most powerful factory faced a challenge that seemed mathematically impossible. As World War II engulfed the globe, the United States government turned to the master of matter with a desperate request. They didn't need cars. They needed the B-24 Liberator, a 4-engine heavy bomber so complex it was considered a miracle of aviation. At the time, aircraft were built by hand in small hangars, with a single plane taking weeks to finish. Henry Ford's son, Edsel, looked at the blueprints and made a claim that shocked the military. "We will build one of these every hour." To achieve this, the River Rouge would have to become the arsenal of democracy, transforming itself from a civilian car plant into the most lethal production machine in human history. The technical hurdle was staggering. A Ford car had about 15,000 parts. A B-24 Liberator had over 300,000 parts and 700,000 rivets. To make the 1-hour goal a reality, Ford applied the Rouge logic of vertical integration to the sky. He built the Willow Run plant as an extension of the Rouge philosophy, a single building so large it had its own weather patterns inside. But the guts of the planes, The massive 1,200 horsepower Pratt and Whitney radial engines were built right in the heart of the River Rouge Complex. Ford engineers didn't just copy the military's engine designs, they redesigned the manufacturing process itself. They replaced hand-fitting with high-speed precision machining, creating interchangeable parts that were so accurate they could be swapped between engines on a battlefield, a concept that was revolutionary for aviation at the time. Inside the Rouge, the City of Fire took on a military discipline. The foundry, which had been pouring engine blocks for V8s, was now casting specialized aluminum alloys for aircraft cylinders. The stamping plant, which had been crushing steel into fenders, was now using massive presses to form the aerodynamic skin of the fuselage. The transition was a logistical nightmare. Every machine had to be recalibrated, every worker retrained, and every conveyor belt rerouted. Yet, because Ford owned the entire supply chain, from the iron ore to the power plant, he could bypass the bottlenecks that crippled other manufacturers. When the military needed a specific grade of steel or glass, the Rouge simply brewed it in its own furnaces and rolled it in its own mills. The result was an industrial output that helped win the war. At its peak, the Ford system was producing a B-24 bomber every 63 minutes. It was a terrifying display of what vertical integration could achieve when focused on a single existential goal. The River Rouge had proven that its machine was not just for transportation, it was a flexible, unstoppable force of nature. But as the war ended and the smoke cleared, the factory returned to building cars for a new, consumer-hungry America. However, the intensity of the war years had left a mark. The pace had become even more relentless, and the tension between the men and the machines was reaching a breaking point. The arsenal of democracy had saved the world, but inside its own gates, a new war was about to begin, a battle for the soul and the rights of the American worker. Despite the mechanical perfection of the River Rouge, there was one component that Henry Ford could never fully control: the human being. By the late 1930s, the Rouge was not just a factory, it was a pressure cooker. To maintain a car-per-minute pace, Ford enforced a regime of discipline that bordered on the totalitarian. He created the Ford Service Department, a private, internal police force of over 3,000 men, many of them former boxers and ex-convicts, led by a ruthless man named Harry Bennett. Their job was simple: ensure that no one talked, no one sat down, and, above all, no one joined a union. In the City of Fire, the machines were treated with reverence, but the men were treated as replaceable gears. This tension reached a violent climax on May 26, 1937, in an event known as the Battle of the Overpass. The conflict took place on the concrete pedestrian bridge leading to Gate 4 of the Rouge. A group of labor organizers, including a young Walter Reuther, arrived to peacefully hand out Union flyers to workers changing shift. They were met by Bennett's Service Department thugs. What happened next was caught on film and shocked the nation. The organizers were brutally beaten, kicked down the stairs, and thrown into traffic. The machine had bared its teeth. Ford believed that by paying a high wage, the famous $5 day, he had bought the total loyalty of his men. But the workers at the Rouge realized that money couldn't buy dignity. They were tired of the speed up, where the assembly line was secretly accelerated every hour to squeeze out more profit at the cost of human health. The Battle of the Overpass was a turning point. It stripped away the image of Henry Ford as a benevolent father of the industry and revealed the Rouge as a place of industrial warfare. The public was horrified by the violence, and the government finally stepped in, forcing Ford to allow his workers to vote on whether to join the United Auto Workers. Even then, Ford resisted, threatening to shut down the entire 2,000-acre complex rather than negotiate. It was only when his wife, Clara, threatened to leave him that the master of matter finally surrendered. In 1941, Ford signed the most generous union contract in history, effectively ending the era of the industrial dictator. The Rouge survived the conflict, but it was changed forever. It was no longer just a place of fire and steel, it was a place of law and right. The City of Fire had to learn to share its power with the men who tended its furnaces. This era proved that while you could automate the pouring of iron and the stamping of steel, you could never automate the human spirit. The Rouge remained the most powerful factory on Earth, but it was now a partnership between the visionary at the top and the thousands of workers on the floor. It was a hard-won peace that would carry the factory through the golden age of the 1950s, until a new threat, not from unions but from the global economy, would finally challenge the king of factories for its throne. By the mid-1970s, the City of Fire was no longer a shining cathedral of progress. It had become a sprawling, smoke-belching monument to a vanished era. The very things that had made the River Rouge a miracle in 1920, the massive coal-fired power plant, the open-hearth steel mills, and the direct pour foundry, had become its greatest liabilities. The world was changing at a speed the Rouge's 2,000-acre skeleton couldn't match. The 1973 oil crisis hit the factory like a physical blow. The American consumer, who for decades had demanded the heavy, V8-powered steel behemoths that the Rouge was designed to churn out, suddenly wanted small, fuel-efficient imports. For the first time in history, the 48-hour miracle felt out of sync with reality. The factory was a high-speed machine designed to build a product the world no longer wanted. As the production slowed, the physical decay of the plant became impossible to ignore. For nearly 70 years, the Rouge had operated on a philosophy of total industrial extraction. It had treated the earth as an infinite resource and the atmosphere as an infinite trash can. The blue ball of smoke that hung over Dearborn, once hailed as the breath of prosperity, was now recognized as a toxic cocktail of sulfur dioxide, carbon monoxide, and particulate matter. The environmental toll was catastrophic. The Rouge River, which Henry Ford had once dredged to welcome the great freighters, had become one of the most polluted waterways in the United States. The water was so thick with industrial grease, discarded cutting oils, and chemical solvents that it was legally classified as a fire hazard. In some sections, the river actually caught fire, a haunting image of an industrial dream turned into a nightmare. Inside the gates, the Kahn-style buildings were failing. The massive glass windows that once allowed natural light to flood the floor were now coated in decades of iron dust and soot, plunging the interior into a permanent, grimy twilight. The vertical integration that was once Ford's greatest strength had become a conglomerate noose. Maintaining a private railroad, a private steel mill, and a private power plant was now vastly more expensive than buying those services from outside specialists. The specialized machines in the engine plant, some of which had been running since World War II, were breaking down. The metallurgy was also suffering. The Malaise-era cars were prone to rapid rusting because the recycled steel from the Rouge's own mills often contained impurities that the aging furnaces could no longer filter out. The human element was also fracturing. The speed-up of the assembly line, combined with the grim, deteriorating conditions, led to a collapse in morale. The factory that had once been the arsenal of democracy was now a place of tension and fatigue. As the 1980s arrived, the question wasn't how much the Rouge could produce, but if it should even continue to exist. Ford began a process of radical disintegration. They sold off the steel mills to the Rouge Steel Company, they divested from the glass plants, and they shut down the aging coke ovens. The closed loop was broken. For the first time, large sections of the 2,000-acre empire fell silent. The legendary blast furnaces, which had glowed white-hot for generations, were extinguished. To many, it looked like the end of the American industrial century. The Rouge was becoming a brownfield, a poisoned stretch of land that was too expensive to clean and too historic to destroy. It seemed destined to join the ranks of the great rusted ruins of the Rust Belt, a silent ghost of a time when America believed that fire and smoke were the only paths to greatness. But the story of the Rouge has always been about the impossible. Just as the wrecking balls were being prepped, a new vision was forming, one that would attempt to marry the raw power of the past with the biological necessity of the future. In the late 1990s, the River Rouge sat at a crossroads between total demolition and a leap into the unknown. Most corporate consultants advised Ford to abandon the site, citing the nearly century-old soil contamination and the high cost of modernizing the Kahn-style ruins. But William Clay Ford Jr., the great-grandson of the founder, saw something else. He envisioned a factory of the future that didn't just manufacture trucks, but actively healed the environment. In 1999, he launched a $2 billion renovation that remains the most significant industrial experiment of the 21st century. The centerpiece of this rebirth was the Dearborn Truck Plant, a facility designed to prove that heavy industry and ecology could coexist. It began with the living roof, a staggering 10.4-acre carpet of sedum, a hardy, low-maintenance plant. This wasn't for aesthetics. It was a high-performance engineering tool. The roof acts as a giant sponge, absorbing millions of gallons of rainwater annually and naturally filtering it, preventing the toxic runoff that had poisoned the Rouge River for decades. The sedum also acts as a massive thermal blanket, reducing heating and cooling costs by nearly 10% and doubling the life of the roof's membrane by shielding it from UV radiation. Inside the plant, the Rouge logic was completely rewritten for the digital age. The deafening, dangerous stamping presses of the 1920s were replaced by high-speed, fully automated hydroforming and laser cutting lines. The most dramatic change, however, was in how the vehicles move. The 27 miles of fixed overhead conveyors, the iron chains that once dictated the life of the worker, were replaced by a fleet of autonomous guided vehicles, AGVs. These are robotic platforms that use magnetic strips and laser guidance to move chassis through the plant with surgical precision. Unlike the old lines, these robots can be reprogrammed in minutes to change the product mix, allowing the Rouge to build both gasoline-powered F-150s and the high-tech electric F-150 Lightning on the same floor. The assembly process is now a symphony of data. Every torque wrench is connected to a central server, ensuring that every bolt is tightened to exact specifications and recorded for the life of the vehicle. The human experience was also fundamentally re-engineered. Ford abandoned the industrial dictatorship of the past in favor of a high-performance team environment. Workers who once spent 10 hours a day in smoke and heat now work in a climate-controlled, naturally lit facility where advanced robotics do the 3Ds, the dirty, dangerous, and dull jobs. Exoskeleton suits are provided to overhead workers to reduce physical strain, and a sophisticated, zero-waste system ensures that 100% of the plant's scrap metal and aluminum is vacuumed from the floor, baled, and sent back to the mill within hours. This is the modern closed loop, a system where the factory literally eats its own waste to survive. Even the toxic soil of the old site was treated with phytoremediation, a process where specific plants were grown to suck heavy metals and toxins out of the ground through their roots, cleaning the earth without the need for massive excavation. Today, the River Rouge is more than a factory. It is a living bridge between two centuries. You can stand on the observation deck and look in one direction to see the 1920s blast furnaces and the deep water docks where the freighters still unload their ore. You look in the other direction and see a state-of-the-art electric vehicle center where the most advanced batteries on Earth are mated to aluminum frames. The City of Fire has become a city of intelligence. The 8 smokestacks of the original powerhouse still stand as a tribute to the sheer grit of the 20th century, but the air around them is clear. The Rouge survived the Great Depression, the fires of World War II, and the collapse of the Rust Belt because it never stopped evolving. It remains the heart of American industry, a 2,000-acre machine that proved that while machines create products, it is the courage to reinvent them that creates a legacy. A century later, the heartbeat of the Rouge is stronger than ever, driving us toward a future that Henry Ford could never have imagined, but would have deeply respected.